and welcome to the CCS Global Tech Talent Development Program. Now, what are relationships? Relationships in data modeling are the connection from one entity to another or an entity to itself. This is usually displayed in several different methods. The different relationships we can have are one-to-one, one-to-many, and many-to-many. In the one-to-one relationship, we have a single instance in one relationship connected to a single instance of another. For example, let's say we have a parking spot entity that is made in a business, and every employee can have one parking spot. This is an example of a one-to-one because that means one parking spot will be assigned to one employee, and one employee will have one parking spot. This is a one-to-one relationship. Next, we have one-to-many, where we have a single instance of one entity connected to multiple instances of another entity. Now, when we say one-to-many, the many leaves it open. There could be 2, 5, 10, 20. We just say many. We just know it's going to be more than one. So this leaves a nice open kind of relationship. For example, let's say we have, let's say we have a father. Right? He can have 1 kid, 2 kids, 3 kids, 4 kids, 10 kids. It's up to him. This is a one-to-many relationship because you can't predict exactly how many instances will occur, but you know it'll be more than one. And then lastly, we have a many-to-many relationship. This is when there are many possibilities or instances from one entity connected to many instances of another entity. In the example to the right, we've shown how you would display these using simple crow feet. As you notice, for a one-to-one relationship, there is just a solid line for both sides, showing 1 and 1. For the one-to-many relationship, we see a solid line from the entity with 1, and then a split at the end for entity 2. This shows many. And then the bottom one, we have many-to-many relationship, where we have the crow's feet or split on both sides. Now, of the relationships that have been listed, there's one of them that we cannot leave as it is. This is the many-to-many relationship. With a many-to-many relationship, trying to retrieve data would be very cumbersome, very slow performing, because we have so many different instances of one connecting to so many different instances of the second one. So with this setup, it would greatly hinder our performance. So we have to fix this. The way we fix this is by adding in a third table in between those two entities connected. And this is called a conjunction table. This conjunction table will have nothing but keys in its data set. These are called composite primary keys, or just composite keys depending on how you use them. Here in this example, we have users and permissions. Now, in a normal IT world, we know that there are many users with many different permissions. Right? If you have a computer at home, you might have admin privileges, which allow you to edit, create, and install software and things like that. But you also might have a standard user set up for an account for maybe a younger brother or sister. And they have their own permissions, but they're not limited to just one. They can maybe edit and see different things, but they may not be able to install or see or be able to operate software in that way. So we have many different permissions. So looking up this information would be taking quite a long time. For finding the user login and all the permissions that they can go to, we would have the data essentially repeating multiple times. So if we were to do something like a query, it would be very slow. However, adding in a conjunction table, we simply take the key from one entity and the key from another entity and then combine them in the conjunction table. Now, in this instance, let's say I want to find out all the permissions that user 1 has. When I go to the conjunction table and I look up user 1, it might say user 1 permission key number 1 admin, user 1 permission key number 2 system administrator, user key number 1 permission key number 3. It'll be listing all of the different keys for the permissions associated with that user's login. This makes it a little bit easier for me to determine what actual permissions a single person has. Another thing in relationships to keep an eye on is participation. Now, what we mean by participation is that not all instances of both entities are always going to be in a relationship. So, for example, let's take our employee parking spot again. We know that an employee is assigned to a parking spot, but not every employee may need a parking spot. So, in this instance, we have the employee entity is only partially participating because only some instances are involved in a relationship. Only some employees will actually need a parking spot. However, for every parking spot that is assigned, that means there must be an employee who needs that, right? So then that side would be considered fully participating. In the example on the bottom, we have employees with their dependents. Now, there's a good chance that every employee has a policy as far as insurance goes, whether it's healthcare or life insurance or whatever. And then we have dependents because that policy must be paid out. Now, not every employee may have the same exact healthcare or policy insurance set up, so this would not be fully participating. However, for dependents, wherever there is a dependent, that means there is someone who has to have the policy in place. So in this, we see that the employees are again partially participating, and the dependents are fully participating. Another example we can think of are employees and the departments. Now, an employee can be the head of a department, but not every employee can be heads of a department, only a few. However, every department must have an employee in charge. So, with the departments, they're fully participating in this relationship, while the employees are partially participating. Now, there are different ways that this can be displayed. Sometimes using an arrow set up like the bottom one we see here shows which one is fully participating and which one is partial. You can simply bold the line of the one that's fully participating, or maybe double line it, and then leave the other one skinny, kind of weak and partial design. Sometimes you might just find it easier to simply leave a little note or annotation. So over the relationship, you might write for one side fully participating and on the other side partially participating. There are different ways of representing this. Now, what is cardinality? Cardinality is the number of times an entity participates actually in the relationship. This doesn't mean we mean one-to-one, one-to-many, or even mean degrees. What we're saying is how many times does that entity in a relationship actually work with that other entity. In the case of, let's say, employee and parking spot, one employee can have one parking spot. So this means the cardinality of employee is 1, and the cardinality of the parking spot is 1. Now, cardinality doesn't mean that it has to be a specific number. Cardinality just means what is the value given. Many is still considered a cardinality, but it is a range. It is anything that is above 1. It can vary in the different elements as far as who or how many instances occur. For having a fixed cardinality, which is one of the types, you have to make sure you have a good reason for using specific cardinalities. Now, most of the time a relationship will be one-to-one or one-to-many. When we have a one-to-one, that's good. We understand that, and we know that only one instance of this can be one instance of that. One employee, one parking spot. One employee and one desk. One person married to one person. This is relatively easy to understand. When we say one-to-many, we know that there can be multiple occurrences on the many side of the relationship. But since we specified many, we can say there might be 2, there might be 5, there might be 10. We don't know what's going to happen. For instance, student taking courses. Now, one student is going to take many courses. But we all know everyone takes a different amount of courses depending on what they can handle. Some students might only take 2 courses, while others might take 6. There's no fixed number there. So cardinality is not a measure of degrees, and it is not a relationship. It is simply saying how many times does one entity participate in the relationship to the other. When we want to specify specific cardinalities, there are 3 things that we typically focus on: a maximum cardinality, a minimum cardinality, and a fixed cardinality. If we want to specify a maximum cardinality, we're going to specify that it can't exceed a certain number. Likewise, with minimum cardinality, we're going to specify that it can't be below a minimum number. Now, one example of this is, let's say, students in the courses. In order to be a student at a college, you must take at least 1 course. But they might have maximum limits. That way a student doesn't burden themselves with too much work. So let's say a college puts in place that a student cannot take any more than 5 courses. So here we have a minimum cardinality of 1, a maximum of 5. When we get to fixed cardinality, we say it must always be a specific number. Now, in a one-to-one relationship, it does count as a fixed cardinality because there must be 1 instance connected to 1 instance. However, let's say we are having a different layout for a different college. Let's say in order to go to an Ivy League college, you must always take 5 courses. So here we would have a 1 to 5 relationship, and this is going to say 1 cardinality must be met with 5 cardinality. 1 student must always take 5 courses. Again, specifying minimum, maximum, or fixed cardinality requires good reason to do so. A one-to-one relationship is okay in understanding and logic, but when we say 1 to 3, 1 to 5, 1 to 8, something like that, we are limiting what can be displayed, versus if we said 1 to many, it could be 2, 3, 4, 5, whatever someone wants, because it's many. So using maximum, minimum, or fixed cardinality limits must have good reasoning behind it, because it takes away that flexibility. It takes away that option you have in the data model to be able to use different numbers and display the information accordingly. You're now limiting it to specific numbers and instances that can be happening. Now, what are degrees? Degrees are simply saying how many entities are involved in a relationship. In a previous video, we talked about the different relationships we had: one-to-one, one-to-many, and many-to-many. Now, just because there's a relationship doesn't mean there has to be 2 entities always used. There can be 1 entity, 2 entities, or 3 entities. The number of entities participating are what degrees explain. Unary means only 1 entity is involved. Binary means 2 entities are involved. And then ternary means that 3 entities are involved. Below we have an example of how you might see some of these degrees being displayed. We see that perhaps in a college you have 1 course that is a prerequisite for another course. In this case, both courses should be in the same entity because they are just courses. So this course will require another course. In this case, we have only 1 entity participating in this relationship, so it is unary. Next, we have a binary one showing professor, teaches, and class. We see 2 separate entities because professor does not mean class, and then we see class also shown. So here we have 2 separate entities participating in the relationship. Next, we have a ternary relationship, a ternary degree. We see a contributor, a recipient, and a fund. So we can see the contributor will have to give a fund to a recipient, and the recipient will receive a fund from a contributor. Now, these are 3 separate entities, all participating simultaneously in this relationship. The most common one you guys will be working with is more likely binary. From time to time, you might have unary, but ternary is going to be often a rare case to have, as with the example seen, ternary is not exactly easy to understand, as far as how it's being displayed here. Unary and binary are much easier to interpret when looking at data modeling because of how we can see it. With the ternary, since we have the three entities all in place, it can be a little hard to understand design because that means all three of these must be participating in the relationship simultaneously. Here we have some more examples to show. Another unary example that might be common is the employee who's managed by employees. In this example to the right, we see a graphical depiction of how this might look. We see employee managed by employee. And that means that manager manages different employees. Here we see a single entity, again, making it unary, but the relationship in it will probably be one-to-many, since a manager is always in charge of multiple employees. So the relationship does not determine the degree. Degree is simply how many entities are in the relationship. Next, we have another example of binary. We see a customer receives an invoice. An invoice is sent to a customer. Now, customer and invoice are two separate entities as they do not relate, so this is why it is binary. And then lastly, we see a ternary example, again with three entities participating simultaneously in this relationship. An operator performs part of the operation. The operation has different parts performed by the operator. The operator of the operation does certain parts. So here we see all the degrees again shown, and we see that it doesn't determine what relationship is happening. I could just as easily had perhaps, let's say, employee married to employee if a couple is working at the same company. Here we would see a one-to-one relationship, but it would still be designed the same way that we see the employee and managers. So degree has nothing to do with relationship, just how many entities are participating. When designing and trying to display degrees, we have a couple of different ways it can be displayed. In Chen's notation, to display a unary degree, we just simply have an entity connected to itself. In crow's feet, we do the same thing, but instead of having the 1 in 1 or the 1 in m, we simply have the different crow's feet for the symbols. Here again, we have person married to person, and employee managed by an employee. Binary, which is probably going to be the most common, is simply going to be one entity connected to another. In this example, we've used crow's feet. So we see one department has many employees. Again, take note that degree does not determine relationship. And lastly, we have a ternary degree design here. We have two examples to the right. Now, ternary, again, is very complicated and sometimes can be a little difficult to describe. Having a ternary relationship might actually confuse people from time to time about what process is actually happening. Oftentimes, what will happen is because there's a lack of knowledge about what's happening in there, you might have other relationships shown or actually attributes on the relationship to kind of help better explain what is taking place. However, ternary is still going to be a rare case of degree design. More likely than not, binary and unary will be far the most common ones that you use in your data modeling process. So this makes things a little simple.